Dear student, today I discuss some important 1 mark, 2 mark, 3 mark and long question related to the chemical kinetics. At first I will do some 1 mark. First question is the unit of rate constant for second order reaction. First option is your mole inverse liter into second inverse. Second option is your mole into liter inverse into second inverse. Third option is your second inverse. Fourth option is your mole into liter inverse second. To calculate the unit of rate constant for any order of reaction, we know a general formula, that is your mole into liter inverse power 1 minus n into second inverse. Here n is the order of reaction. Our aim to find out the unit of rate constant for second order reaction. Here n is equal to 2. So now put the value of n is equal to 2 here. Then we can write mole into liter inverse to the power 1 minus 2 into second inverse. If I will solve this, then I can write mole into liter inverse power minus 1 into second inverse. Then we can write mole inverse into liter to the power 1 into second inverse. Look at that, here mole inverse liter into second inverse is written. So the option A is your correct. Next question is your 75% of a first order reaction completed in 32 minutes. 50% of reaction will be completed in days. That means how many times you need to complete 50% of that reaction. We know that K is equal to 2.303 divided by T log of A by A minus X. This is the equation for rate constant for a first order reaction. For 75% completion, we can write K is equal to 2.303 divided by T. T means here, that is your 32 minutes. Into log of 100 by 100 minus 75. That means we can write 2.303 divided by 32 log of 100 by 25. Similarly, for 50% completion, we can write K is equal to 2.303 divided by T50. Our aim to find out the T50. Then we can write log 100 by 100 minus 50. Finally, you can find 2.303 divided by T50 into log of 100 by 50. For a particular reaction, we know that the K value is constant. Look at that, here K is written, here also K is written. That means the left hand side is now equal. So we can write 2.303 divided by 32 log of 100 by 25 equal to 2.303 divided by T50 into log of 100 by 50. Suppose this is your equation 1, this is your equation 2. We can write from equation 1 and 2, we can write 2.303 divided by 32 log 100 by 25 is equal to 2.303 divided by T50 into log 100 by 50. Now cancel the 2.303 here. Now I can write 1 by 32 log of 4 is equal to 1 by T50 into log of 2. Here I can write T50 is equal to 32 into log 2 divided by log 4. Now I can write T50 is equal to 32 into log 2 divided by, you can write here 2 into log 2 Now cancel log 2 implies that T50 is equal to 16 min naught. In our question there are 4 options given. One is your 24 minutes, second is your 16 minutes, third is your 8 minutes, fourth is your 22 minutes. So our answer is your option B, that is your 16 minutes. Next question is the hydrolysis of ethyl acetate in acidic medium is a reaction of dash order. It is a first order, remember. Next question is your calculate the order of reaction having the rate expression. That is your rate is equal to K into concentration of A power 1 by 2 into concentration of B power 3 by 2. For calculation of order of reaction, it is bound to add the power of the concentration of the reactant. That means the order of reaction equal to 1 by 2 plus 3 by 2. Now the LCM is your 2. Here I can write 1 plus 3. That means 4 by 2 is equal to 2. That means the answer is your second order reaction. Next question is your what is the unit of first order reaction? For calculation of order of reaction, we can apply general formula mole into liter inverse power 1 minus n into second inverse. Here n is equal to 1 because I want to calculate the unit of rate constant for first order reaction. Now put here n is equal to 1. Then we can write mole into liter inverse to the power 1 minus 1 into second inverse. That means here I can write mole into liter inverse power 0 into second inverse. Finally, the unit of rate constant is your second inverse. So our answer is second inverse. Next question is your what is Arrhenius equation? Arrhenius equation is your K is equal to A into e to the power minus A by RT. This is your said to be Arrhenius equation. Here K is equal to rate constant, A is equal to Arrhenius constant, or it is also called frequency factor. Here E is equal to activation energy, R is equal to gas constant, T is equal to temperature. Now I will discuss some important 2 and 3 mark question related to the chemical kinetics. First question is the rate constant of a first order reaction is 0.6 second inverse. What is its half life period? Here rate constant, that is your K, equal to 0.6 second inverse. Our aim to find out the T half. For a first order reaction, we know that T half is equal to 0.693 divided by K. Now put the value of K here, then we can write 0.693 divided by 0.6. After solving, the value of T half is your 1.155 second. Therefore we can write half life period equal to 1.155 second. The second question is your calculate the rate constant of a first order reaction which is 90% complete in 10 minutes. Here T is given, that is your 10 minutes. Here 90% completion is given, that means let A is equal to 100, then according to the question X is your 90, then A minus X is equal to 100 minus 90, that is your 10. We know that K is equal to 2.303 divided by T log of A by A minus X. Our aim to find out the value of K. So here we can write question mark. Now put the value of A minus X and also T in this equation. Then we can write 2.303 divided by 10 into log of Your a is your 100 and a minus x is your 10. Imply that we can write k is equal to 2.303 divided by 10 into log 10, because 100 by 10 is your 10. Imply that k is equal to 2.303 divided by 10 into 1, because the value of log 10 is your 1. So we can write k is equal to 2.303 divided by 10, that is your k is equal to 0.2303 second inverse. So we can write rate constant equal to 0.2303 second inverse. Now I will solve the question number 3, so that the time required for first order reaction to go 99% completion is 10 times the half-life period. That means our aim to prove that T99 equal to 10 into T50. That is, you can also write T half. There are two cases. Case number 1 is your for T99.9. Case number 2 is your for T50. For case number 1, let A is equal to 100. According to the question, for case 1, x is equal to 99.9. Therefore, a minus x is equal to 100 minus 99.9 equal to 0.1. We know that k is equal to 2.303 divided by t means here T99.9 into log of a by a minus x, that means here log 100 by 0.1. For case 2, let a is equal to 100. According to question, for case 2, x is equal to 50. Therefore, a minus x is equal to 100 minus 50, that is your 50. Here we can also write k is equal to 2.303 divided by t50 into log of 100 by 50. Suppose this is your equation 1, suppose this is your equation 2. From equation 1 and 2, we can write 2.303 divided by T99.9 into log of 100 by 0.1 equal to 2.303 divided by T50 into log of 100 by 50. For a particular reaction, the value of k is constant, so we can write this relation. That means 2.303 divided by T99.9 into log of 100 divided by 0.1 equal to 2.303 divided by T50 into log of 100 by 50. Here cancel 2.303. Next I will write 1 by T99.9 log of 100 into 10 is equal to 1 by T50 log of 2. Next I will write log of 10 to the power 3 divided by T99.9 equal to log 2 divided by T50. Now T99.9 equal to T50 into log 10 to the 3 divided by log 2. Now I can write T99.9 equal to 3 log 10, because log 10 to the 3 is equal to 3 log 10. Now divide log 2. Here we can write T50. Imply that T99.9 equal to 3 into 1 divided by 0.3010 into T50. Here 1 is written because the value of log 10 is your 1. Here 0.3010 is written because the value of log 2 is your 0.3010. After solving, we can write T99.9 equal to 9.969 into T50. That means I can write T99.9 is equal to 10 into T50. our aim to prove T99.9 equal to 10 into T50. Now this is your proved. Here we can write proved. Here I can write proved. Next question is your for a reaction. A reaction is given A plus B gives C product. The rate law is given. That means R is equal to K into concentration of A power 1 by 2 into concentration of B power 2. This expression is written for the rate constant according to the rate law. Then what is the order of this reaction? Order of reaction means 1 by 2 plus 2, that is your 2.5. Then another question is also given. Write the definition of order of reaction. Look at that. It is the sum of power of molar concentration of the reactant in the rate law. Order of reaction means sum of power of molar concentration of the reactant in the rate law. Now I will solve the question number 5. Here a table is given. There are two experiments. 1, 2. Here the concentration of A is given in moles per liter. For experiment 1, the value is 1.0. For experiment 2, the value is 2.0. Here also the concentration of B is also given in moles per liter. For experiment 1, the value is 2.0. For experiment 2, the value is also 2.0. Here rate is given. The rate is given in mole into liter inverse into second inverse. For experiment 1, the value is 2.25 into 10 to the minus 3. For experiment 2, the value is 4.5 into 10 to the minus 3. A reaction is given. A plus B gives a product. For this reaction, the table is given. Our aim to find out the order of reaction with respect to A. According to the table, I can write 2.25 into 10 to the minus 3 equal to K into concentration of A means 1.0 power. Suppose I will take P. Here P is order of reaction with respect to A. Then I multiply with this into concentration of B. Here concentration of B is 2.0. That means I can multiply this with 2.0 power Q. Here Q is the order of reaction with respect to B. Suppose this is your equation number 1. Similarly I can write 4.5 into 10 to the minus 3 equal to K into 2.0 power P into 2.0 power Q. This is your equation number 2. From equation 1 and 2, I can write 4.5 into 10 to the minus 3 divided by 2.25 into 10 to the minus 3, which is equal to K into 2 to the P into 2 to the Q divided by this. That means I can write here K into 1 to the power P into 2 to the power Q. Now cancel this term and also cancel this term and also cancel this term. Look at that. Here 4.5 is given. Here 2.25 is given. That means when 4.5 is divided by 2.25, then 2 is obtained. So here we can write 2 equal to 2 to the power P divided by 1 to the power P. That means I can write 2 to the power 1 is equal to 2 to the power P. Therefore here I can write P is equal to 1. P is the order of reaction with respect to the reactant A. Therefore I can write the order of reaction with respect to A equal to 1. Next I will solve the question number 6. The decomposition of A into product has value K as 4.5 into 3 second inverse at 10 degree centigrade, and the energy of activation equal to 60 kilojoule mole inverse. At what temperature would K be 1.5 into 4 second inverse? That means here K1 equal to 4.5 into 3 second inverse. K2 is equal to 1.5 into 4 second inverse. EA equal to 60 kilojoule mole inverse. We can write also 60,000 joule into mole inverse. Here P1 is 10 degree centigrade. That means here I can write 273 plus 10, that is 283 Kelvin. T2 is not given. It is your aim to find out T2. We know that log K2 by K1 equal to EA by 2.303 R into T2 minus T1 divided by T1 T2. Now put all the value in this equation, then we can write log of 1.5 into the 4 second inverse divided by 4.5 into the 3 second inverse equal to 60,000 divided by 2.303. The value of R is your 8.314 joule into Kelvin inverse mole inverse. Here T2 is our aim to find out. T1 is 283 Kelvin divided by 283 into T2. By solving this, we can write log of 10 by 3. By solving this term, I can write 3133.62. Then I can write 3133.62. Then I can write T2 minus 283 divided by 283 T2. Now I can solve like this. Log 10 minus log 3 equal to 3133.62 into T2 minus 283 divided by 283 T2. Imply that I can write 1 minus the value of log 3 is 0.4771 is equal to 3133.62 into T2 minus 283 divided by 283 T2. Now solve this, then I can write 0.5229 equal to 3133.62 into T2 minus 283 divided by 283 T2. Now I can write 0.5229 divided by 3133.62 is equal to T2 minus 283 divided by 283 T2. By solving this term, I will get 1.67 into the minus 4 equal to T2 minus 283 divided by 283 T2. After solving, we can able to find out the value of T2 is equal to 297.02 Kelvin. Our question is at what temperature would K be 1.5 into the 4 second inverse. So we can write the temperature is equal to 297.02 Kelvin. Next I will solve the question number 7. The rate of reaction quadruples when the temperature changes from 293 Kelvin to 313 Kelvin. Calculate the energy of activation of the reaction, assuming that it does not changes with the temperature. In this problem, T1 equal to 293 Kelvin, T2 is equal to 313 Kelvin. Here a point is given, the rate of reaction quadruples. That means here K2 by K1 is your 4. We know that log K2 by K1 is equal T1 divided by T1 T2. Put the value of T1 T2 and also K2 by K1 in this equation, then I can write log 4 equal to EA by 2.303 into 8.314, because the value of R is equal to 8.314 joule into Kelvin inverse mole inverse. Now put the value of T1 and T2, then I can write 313 minus 293 divided by 293 into 313. Next I can write log 2 square is equal to EA by 2.303 into 8.314 into 20 divided by 293 into 313. Imply that we can write 2 log 2 equal to EA divided by 2.303 into 8.314 into 20 divided by 293 into 313. Now I can write 2 into 0.3010, because the value of log 2 is equal to 0.3010 is equal to EA by 2.303 into 8.314 into 20 by 293 into 313. Imply that EA is equal to 2 into 0.3010 into 2.303 into 8.314 into 293 into 313 divided by 20. Imply that EA is equal to 52863.33 joule per mole. We can convert the joule into kilojoule. Then I can write EA is equal to 52.86333 kilojoule per mole. Our question is to calculate the activation energy. Therefore, activation energy equal to 52.86333 kilojoule per mole. Next, I will solve the question number 8. The half life of two samples are 0.1 and 0.4 seconds respectively. Their respective concentration are 200 mole per liter and 50 mole per liter respectively. What is the order of reaction? In this problem, T half 1 is equal to 0.1 second, T half 2 is your 0.4 second. This is given. A1 equal to 200 mole per liter, A2 is equal to 50 mole per liter. We know that T half 1 divided by T half 2 equal to A1 divided by A2 whole to the power 1 minus n. Here n is the order of reaction. Our aim to find out the order of reaction. Now put the value of T half 1, T half 2, A1, A2 in this equation. Then I can write 0.1 divided by 0.4 equal to 200 by 50 whole to the power 1 minus n. Imply that 1 by 4 equal to 4 to the power 1 minus n. Imply that 1 by 4 equal to 1 by 4 whole to the power n minus 1. Imply that 1 by 4 whole to the power 1 equal to 1 by 4 whole to the power n minus 1. Now I can write 1 equal to n minus 1. Imply that n is equal to 2. Our question is find out the order of reaction. So we can write order of reaction equal to 2. That means we can think about the second order reaction. These are the other important 2 and 3 mark questions. First question is what is rate law and explain the rate law. The rate law is also called rate equation. Suppose I will take an example. AA plus BB gives a product. Rate law is nothing but it is a mathematical expression which is written by the help of terms of the concentration of the reactant which actually influence the rate of reaction. Suppose I will think about this reaction. Here A mole of A reactant is taken which react with the B mole of B reactant, then the product is obtained. You cannot say that the A mole of A and B mole of B will affect the rate of reaction. It may or may not. Suppose P mole of A and Q mole of B will affect the rate of reaction, then we can write R is equal to K into concentration of A power P into concentration of B power Q. Remember an important point, here A equal to P or not equal to P. Here B equal to Q or not equal to Q. That means A and B value may or may not equal with the P and Q respectively. This is your called rate of reaction according to rate law or rate equation. Suppose I will apply the law of mass action, then the rate of reaction can be written like this. R is equal to K into concentration of A power A into concentration of B power B. Suppose I will take a reaction 2NO2 react with the F2 gives the 2NO2F. Remember in this reaction 2 mole of NO2 is taken which react with the 1 mole of F2. So according to the law of mass action, I can write the rate of reaction like this. R is equal to K into concentration of NO2 power 2 and concentration of F2 power 1, or you cannot also write 1. This is the expression according to the law of mass action. Suppose I want to write the rate of reaction according to the rate law, then it is bound to know how many moles of reactant will affect the rate of reaction. Experimentally it is seen that 1 mole of NO2 and 1 mole of F2 affect the rate of reaction actually. So I can write the rate of reaction expression according to the rate law like this. R is equal to K into NO2 concentration power 1 and here I can write F2 concentration power 1, or you also cannot write 1. This is the difference between rate of reaction according to the rate law and law of mass action. Remember an important point, the rate of reaction according to rate law can be written by the help of experimental data, otherwise it cannot be written. In this question, it is bound to write the postulates and failure of the collision theory. The postulates of collision theory are: the reactants are made by molecules. Suppose I will take a reaction CO plus NO2 gives CO2 plus NO. In this reaction, the CO and NO2 are considered as the reactant and CO2 and NO are considered as the product. According to this theory, the reactants CO and NO2 are considered as the molecule. That means the CO and NO2 are made by molecules, and these molecules are always present in a container in a random motion. That means they move in random way. Due to their randomness, the molecules collide with each other. As a result, collision will possible, and this intermolecular collision will responsible for the reaction. Remember an important point: All the collision which is done by the help of CO and NO2 are not responsible for a reaction. Only effective collisions are responsible for the reaction. The collision which obey two conditions, one is your energy barrier, another is your orientation barrier, is called effective collision. That means an effective collision must obey two conditions, one is your energy barrier, another is your orientation barrier. Energy barrier means it attains the threshold energy. Orientation barrier means the molecules are collide in such a way that as a result the proper oriented product is formed. For example, suppose the CO molecule is present like this, then the NO2 molecule must be present like this. When they collide with each other, as a result the proper oriented carbon dioxide molecule is formed. That means we can draw like this. This is the orientation of carbon dioxide molecules. And the other product is also written like this. This is also said to be proper orientation. If the CO molecule collide with the NO2 molecule in this way, then there is no formation of the suitable product. As a result, this collision is said to be ineffective collision due to the improper orientation of the NO2 molecule. That means totally this collision is considered as the ineffective collision, and such type of ineffective collision do not responsible for the reaction. These are the postulates of collision theory. Now I will explain about the failure of collision theory. This theory unable to explain the abnormal value of rate constant for some reaction. The second failure is for some reaction the calculated and the experimental value are different with each other. This theory fails to explain about the rate constant for a reversible reaction which having low value of K. There is a main failure in the collision theory. This theory cannot give the correct number of collision before the reactant molecule collide effectively. These are the failure of the collision theory. Next question is your distinction between order and molecularity of a reaction. It is a very important question, always asked in the annual exam. Now I will explain about the distinction between order of reaction and molecularity. Order of reaction completely depend upon the rate law, that is your rate equation. Order of reaction is the sum of the power of the molar concentration which are written in the rate law are called order of reaction. Molecularity means the number of reacting molecule taking part in a single step of the reaction is called molecularity. Remember another point, order of reaction may be fraction, may be zero, and also you can think about it is also a whole number. But remember, molecularity always a whole number. It cannot be zero, or that is also it cannot be also fraction, because when we think about a reaction, then we always think about there must be some molecule or atom or ions. Without molecule, atom or ions, a reaction cannot be possible. And it is also very difficult to take fraction of the molecule and it is predict to reaction, because the fraction of molecule is highly unstable. So remember an important point, molecularity cannot be fraction, molecularity cannot be zero. Molecularity always a whole number. That means you can take one molecule, two molecule, three molecule like that. Order of reaction pertains whole reaction. That means order of reaction means it indicate whole the reaction. That means it indicate completely about the reaction. But remember, molecularity of a reaction cannot pertain whole of the reaction. It only pertain a single step of a reaction. Always remember, order of reaction can be calculated experimentally. That means it needs the help of the experimental data. when we will do experiment, then what amount of reactant actually affect the rate of reaction, accordingly the order of reaction can be calculated. But remember, molecularity do not depend upon the experimental data. It only depends about the single step reaction. In a single step, how many number of molecules take part in the reaction, that is considered as the molecularity. That means the molecularity can be calculated by simply balancing the equation. Order of reaction do not refer the mechanism, but remember molecularity always refer the mechanism. These are the distinction between order and molecularity. Next question is define molecularity and give an example of unimolecular reaction. Sometimes also question ask define molecularity, give an example of bimolecular reaction, or question will ask trimolecular reaction, like that. Molecularity means the number of reactant molecule taking part in the single step. That is the definition of the molecularity. Molecularity means number of reactant molecule taking part in the single step reaction, that is called molecularity. Suppose I will think about the example of unimolecular reaction, then I can give PCl5 gives PCl3 plus CO2. This is an unimolecular reaction. Next question is define order of reaction. Give an example of second order reaction. Order of reaction means it is the sum of the power or exponent of the molar concentration of the reactant in the rate equation. And I will take an example of second order reaction. H2 plus I2 gives 2HI. This is a second order reaction. Also I can make a new question, define order of reaction, give an example of first order reaction, or question can also ask give an example of zero order reaction, like that. Next question is what is half-life period, give an expression for half-life period for first order reaction. Half-life period is the time in which the concentration of the reactant reduced to 1/2 of the initial concentration. Suppose I will take a reaction, A gives a product. At the initial stage, suppose I will take A mole of the reactant A, then how much time is needed to reduce the A mole into A by 2 mole, that is called half-life period. That means the time in which A mole of A reactant is reduced to A by 2 mole of A reactant, that is called half-life period. Next is give an expression for half-life period for first order reaction. We know that for first order reaction the rate constant K is equal to 2.303 divided by T log of A by A minus X. According to the definition of half-life period, we can write T is equal to T half and X is equal to A by 2. Now put this value in this equation, then I can write K is equal to 2.303 divided by T log of A by A minus A by 2. Then I can write K is equal to 2.303 divided by T half. Here also I can write T half. Then here I can write log A by 2. That means I can write K equal to 2.303 divided by T half log 2. The value of log 2 is 0.3010. So I can write K is equal to 2.303 divided by T half into 0.3010. Finally, I can write T half is equal to 0.693 divided by K. This is the expression for the half-life period for first order reaction. Next question is what is activation energy? What are the application of activation energy? Activation energy is the extra energy which is supplied to the reactant. As a result, the reactant attain the threshold energy. That's why the reactant can able to start the reaction. So we can write EA plus ER is equal to ETH. Here EA is the activation energy, ER is the energy of the reactant, ETH means threshold energy. Remember an important point, every reactant have a certain amount of energy, that is called reactant energy, that is the energy of the reactant. When we apply activation energy, then the reactant attain the threshold energy. That's why the reaction can start. There are many applications of activation energy. By knowing the activation energy, we can able to determine the other condition of the reaction. That means we can think about the pressure, catalyst like this. By the help of activation energy, we can calculate the number of effective collision. For an explosive reaction, the activation energy is very low. Activation energy is very low because such type of reaction do not need any extra amount of energy. It has a sufficient amount of energy. As a result, it can start itself its reaction. These are the application of activation energy. That is all about some important 2 and 3 mark questions related to the chemical kinetics. Next I will discuss some important long questions regarding to the chemical kinetics. First long question is your derive an expression for rate constant of first order reaction. Derive the half-life period from the rate equation. A first order reaction takes 69.3 minutes for 50% completion. How much time will be needed for 80% completion? First question is your derive an expression for rate constant for first order reaction. We know that in first order reaction, the rate of reaction depends upon the concentration of only one reactant. Suppose I will take a reaction A gives B plus C. At the initial condition T is equal to 0, suppose A moles per liter of A is taken. At the time 0 mole of B is formed, also 0 mole of C is formed because there is no reaction. Suppose after time T, X mole of A is converted into the product. So I can write at time T the concentration of B is X mole per liter and the concentration of C is X mole per liter, and the A having concentration, that is A minus X mole per liter. This is the concentration of A after time T. This is the concentration of B after time T. This is the concentration of C after time T. We know that the instantaneous rate, that is your dx by dt is equal to K into concentration of A power 1. That means I can write dx by dt is equal to K into A minus X power 1. Now I can solve like this: dx by A minus X equal to K into dt. Now integrate the above equation. Then I can write integration of dx by A minus X equal to integration of K dt. Now solve the integration. Then I can write minus ln A minus X equal to KT plus C. Here C is the integration constant. Our aim to find out the value of C. So I can apply the condition when T is equal to 0, X is equal to 0. Now put this condition in this equation. Then I can write ln A equal to C. Suppose this is your equation 1, this is your equation 2. From equation 1 and 2, I can write minus ln A minus X equal to KT minus ln A. That means I can write ln A minus ln A minus X is equal to KT. Now I can write ln A by A minus X is equal to KT. Imply that I can write K equal to 1 by T ln A by A minus X. Now convert the ln into log. That means I can write K is equal to 2.303 divided by T log A by A minus X. This is the expression for the rate constant for the first order reaction. Now I will derive an expression for the half-life period for the first order reaction. Half-life period is the time in which the reactant is reduced to half of the initial concentration, that is said to be a half-life period. According to the definition, T is equal to T half, X is equal to A by 2. Now put this value in this equation, then I can write K equal to 2.303 divided by T half log of A by A minus A by 2. Imply that K equal to 2.303 divided by T half log A by 2. That means I can write K equal to 2.303 divided by T half log 2. Imply that K equal to 2.303 divided by T half. Now put the value of log 2, that is 0.3010. Imply that T half is equal to 0.693 divided by K. This is the expression for the half-life period for the first order reaction. Now I will solve a problem related to the first long question. The first order reaction takes 69.3 minutes. That means here T is given, that is your 69.3. For 50% completion, that means you can think about T half is equal to 69.3 minutes. In this question T half is given. How much time will be needed for 80% completion? That means our aim to find out the T80. By the help of T half, we can find out the value of K. We know that K is equal to 0.693 divided by T half. That means we can write here 0.693 divided by T half means 69.3. By solving, we can find 0.01 second inverse. For T80, we can write 2.303 divided by K log of A by A minus X. Here A is equal to 100 let, therefore X is equal to 80. Now put the value, we can write T80 is equal to 2.303 divided by K means 0.01. Here I can write log 100 by 100 minus 80. That means T80 is equal to 2.303 divided by 0.01 into log of 100 by 20. Now I can write T80 is equal to 2.303 divided by 0.01 log 5. Now I can write T80 is equal to 2.303 divided by 0.01 into log 10 by 2. Your log 5 is given, that means I can write log 10 by 2. T80 is equal to 2.303 divided by 0.01 into log 10 minus log 2. But that T80 is equal to 2.303 divided by 0.01 into 1 minus 0.3010. The value of log 10 is 1, the value of log 2 is 0.3010. That means I can write T80 is equal to 2.303 divided by 0.01 into 0.699. But that T80 is equal to 160.9797 minutes. So the answer is your 160.9797. In our question, how much time will be needed for 80% completion? So we can write 160.9797 minutes is needed for the 80% completion. Next I will discuss about the second long question. The second long question is derive an expression for rate constant of zero order reaction. Give an expression for half-life period for zero order reaction. For a chemical variation in rate with which shown on the below, a graph is drawn here. What is the order of reaction? What is the units of rate constant K for the reaction? At first, I will derive an expression for rate constant of zero order reaction. Suppose I will take a reaction, A gives the product. At initial condition T is equal to 0. Suppose the concentration of A is your A moles per liter. At initial condition, the concentration of product is your 0. After time t, suppose x mole of A is converted into the product. Now the concentration of the product is your x mole per liter, and the concentration of A is your A minus x mole per liter. According to the definition, zero order reaction means the reaction in which the rate of reaction is independent upon the concentration of the reactant. According to this definition, I can write dx by dt is equal to k into concentration of A power 0, because it belongs to zero order reaction. Now I can write dx by dt is equal to k into concentration of A means A minus x power 0. Here I can write dx by dt is equal to k. That means I can write dx is equal to k into dt. Now I integrate this equation, so I can write integrate the above equation. As a result, I can write integration of dx is equal to integration of k dt. Implies that I can write x is equal to kt plus c. C is your integration constant, Our aim to find out the value of C. So I can apply the condition x is equal to 0, t is equal to also 0. Now put this value here. As a result, I can write C is equal to 0. Suppose this is your equation 1, this is your equation 2. From equation 1 and 2, I can write x is equal to kt. That means I can write k is equal to x by t. This is the expression for rate constant for zero order reaction. Next question is your given expression for half-life period for zero order reaction. That means according to the definition of half-life period, t is equal to t half and x is equal to a by 2. Now put this value in this equation, then I can write k is equal to a by 2 divided by t half. That means I can write t half is equal to a by 2k. This is the expression for half-life period for a zero order reaction. Next question is your graph is drawn. In x-axis, concentration of reactant taken. In y-axis, rate is taken, and a straight line is drawn which is parallel to the concentration of the reactant axis. Then the question is what is the order of reaction? What are the unit of rate constant k for the reaction? Look at that. This is the straight line which is parallel to the concentration of the reactant. From this graph it is clear that the rate of reaction is independent upon the concentration of the reactant. Whether the concentration of the reactant increases or decreases, no problem, but the rate always constant. According to the definition of the zero order reaction, the reaction in which the rate of reaction is independent upon the concentration of the reactant, that is called zero order reaction. That means this graph indicates zero order reaction. So our first question is what is the order of reaction? The answer is your zero order reaction. Second question is what is the unit of rate constant k for the reaction? For calculation of rate constant, we know a general formula: mole into liter inverse power 1 minus n into second inverse. Here n is the order of reaction, so put here n is equal to 0 because it is calculated for zero order reaction. So we can write k equal to mole into liter inverse 1 minus 0 into second inverse. So the unit of k equal to mole into liter inverse second inverse. This is the unit of k for zero order reaction. The question is what are the unit of rate constant k for the reaction? The answer is mole into liter inverse second inverse. This is all about your revision regarding about the chemical kinetics.